Hello class, welcome to Helix and spirals and curves and the threads. I gave you guys a little part here just to get started, and you can work on it in any order you want, but this is kind of like the exercise to help you understand. Actually, let me see this one. So I want to delete that one. Sketch 8. Yes. So let's go to our helix and curves. If you go up here, this is where your command is. Helix and spiral. So let's just go over basically your helix is you're creating a spiral curve. You can either do a spiral up on the axis, like threads, stuff like that, or you can vary it to either cone up or cone out. And you can also do spirals, which is just taking the same thing, a helix, but doing it in only 2 dimensions. Start from the center and spiral your way out, or spiral in. So once you select the helix and spiral, you can select the plane. For our stuff, I did everything on the top plane. So select the top plane, and I'm just going to pick this one. I'm saving this one for composite curves because it just makes it a lot easier. So if you want to make yourself easier, you can pick any of these to work off of, but I just made this easy so you can have everything lined up in one part so you can look at it. So I'm going to just show you the basics. So the first thing you do, we pick the plane. You're going to pick where you want to start your helix. And I'm going to make these 20, 25 radius or 50. So once you create your circle, basically every helix or curve starts with a circular sketch. Once you create it where you want to create it, get out of your sketch mode, and as soon as you get out of your sketch mode, it goes into the helix mode. So let's just go over the basics real quick of what we got in our helix. We've got our choices for a helix. You got 3 choices: pitch and revolution, height and revolution, and height and pitch. So pitch and revolution gives you the pitch. Pitch would be the distance between each spiral. So distance between, let's say, this first spiral and the second. Right now, pitch 50 millimeter. This thing's only in 1 revolution. Let's drop it down to 10 millimeters, and let's go 10 revolutions just so you can see it. So, like I say, pitch is the distance between each of your spirals. You go 360 degrees on one spiral, the distance in between each of those spirals, that's your pitch. And when we're on pitch and revolution, we are saying that we're having our pitch, we're setting the pitch, here 10 millimeters. Our revolutions, we're going 10 times around. If I drop that down, 5, just half. So basically the height, the overall height, is based off of our pitch and how many revolutions we go. Let's go back to 10 again, just so it's clear. And reverse direction is just going to take where our plane is, and it's going to put it on the other side. That's reversing direction. Clockwise and counterclockwise is technically, let's say, like if you're dealing with a thread, it's called a reverse thread. Just it switches the direction. So if I switch this, it switches the direction that the helix goes. Clockwise, always looking down from the top, goes this way. Counterclockwise goes the opposite. So basically looking down on top of your helix is the clockwise and counterclockwise. Now start angle here is where does the helix start? And we're on the top plane, so basically your x and y. Right now it's at 270, so it's starting basically all the way around. 0, let's say we want to start at 0, is starting right here. 90, starting at the right. So Mars, if you're going through the y, x, y, and z, this is our 0, 90, 180, 270. So depending on where you want that helix to start, put in the angle exactly where you want to start. So that is the main things right here. Also, constant pitch, variable pitch, we'll go over that in another example. But right now the constant pitch is what we're talking about, where our pitch is always the same width. So we're talking 10 millimeter pitch right here, right now. That's what we're doing. Taper helix is another one on here that we could set, and this is where I kind of think of it as like a Christmas tree. You can taper when you select the deselect the taper outward. We're taping inward, and it goes from the base upward. So let's say I want a let's just do a simple one, 10 degrees. 10-degree taper. So basically from the vertical, we're talking 10 degrees from the vertical, and notice how it slowly spirals up. It keeps the pitch 10, but slowly decreases the diameter of your helix. Now if we taper outward, it's going to do the opposite. It's going to make it larger and larger as it comes up. So that's what the taper helix does. So back to our three choices for helix or helices. We covered pitch and revolution. Now let's go for height and revolution. Height and revolution just is now you're going to distinguish how tall you want the helix to be and how many revolutions. Now, this is good if you, let's say you're doing actually a spring and you're going to do configurations like in an assembly. Well, if you keep the revolutions, then your spring is going to remain the same, basically the same size, the same amount of revolutions. But then if I change the height, see we got 10 revolutions. If I change the height, right now it's 100 millimeters, let's go 50. It's as if I took the spring and I squished it down. It's still got the same amount of revolutions. I just changed the actual pitch. So this is how you can just set the height and the number of revolutions, and you can just automatically change the pitch depending on if you're squishing it. Let's say I went the opposite. It was at 100. Let's go 150. Now, same amount of revolutions. It's like having the same spring. I just stretched it out. So this is good if you're going to do a configuration. Now let's go to height and pitch. Now this one is you're going to specify the exact height, how high you want it to be, but then you want a specific pitch in between. So this would be good for, like, say you're defining a thread, external or internal, if you're going to do it manually. SolidWorks has gotten smarter in the, I think it's actually since it was 2016 version. I remember I had 2015, and then I had to do threads manually. And then 2016 had a new function, the thread function, and that's takes care of a lot of the work out of it. But if you're going to do threads manually, this is what you're more likely want to do, because you want your pitch to be constant. If you're having like a 1/4-20 bolt or nut, internal or external thread, that -20 is 20 threads per inch. Therefore, you want your pitch to remain constant, but you're going to vary your height. Maybe you got a longer bolt, or you're tapping inside something deeper. So that's where this would come in handy. So that is your height and pitch. Once you're done, let me go back to pitch and revolution. Let's go pitch. Let's go pitch of 10 again. Let's bring it back down. Revolution's 10. Once you're done, all you have to do is select the check mark. And technically what a helix does, it just gives you a three-dimensional line curve. It's not really anything useful right now. You're going to have to go and do a sweat boss later to actually make use of it. So let's hit the sweat boss. It's already done the helix path because I had that highlighted. And just for showing you right now, we're going to do another exercise where we're going to do actually a sketch profile. But right now, we're just going to do a circular profile. And that's how you do it. You can set the diameter. This will just create a circular path around it. Thin feature, that's kind of cool. If you want to do a tube, let's say I had increase the diameter a little bit. But if you select the thin feature, you can select the diameter, and it makes you a tube. Always keep show on the options, show full preview. You can keep merge result because you want it to be continuous. We're not dealing with these two options right now, the merge tangent faces and the align with faces. And your thin feature is one direction. You can do mid-plane, and it will change your thickness. You can do two directions if you wanted to basically specify thickness inward and thickness outward. Just do one direction. Feature scope, selected bodies, auto select. Pretty much auto select will take care of it for you. Curvature display, you can, we're not even going to deal with this right now because you can select different the way it views. But we're just creating a part, so we're not going to worry about that. So let me take away the thin feature again. So with circular profile and your sweat boss, you select, and you have a helix. So that's the basics of a helix, and now we'll go into other types.